All right, so let's get started with our first topic, which is we need to discuss why limits are necessary or important anyway. So, in order to do this, I have a graph here. Let me open it up for you of the function sine of x divided by x. And so, actually, if you look up here in the upper left hand corner, you'll see our function. We're going to call it f of x, and this is a fun little program. It color codes everything, so you can see up here is the function, but down here is the graph of the function also in green. Sine functions we expect are going to kind of oscillate up and down, which is what we see here. This is different than a typical sine function though. By dividing by x, we can see that as we're going to negative infinity and to positive infinity, it's like the graph is fading, and the highest point in the graph appears to be right here at x equals 0. But we have a little bit of a problem because we know from past experience that if x is 0 in a function like this, we are going to get what we call affectionately an error, right? Because it's sine of x divided by x, so if x is 0, we're going to be dividing by 0, and we know we're not allowed to do that. So we should see that there is some kind of disruption in the graph that's caused by dividing by 0. So let's look back. Do we see a disruption in the graph? And I'm going to say, no, it looks totally normal, right? We have this great graph. It looks like it's carrying on here. Nothing special seems to be happening at 0. So just to make this like clearer, I guess, so we can examine this in a better way, I have a nice table of values. It's kind of your typical t-chart. We have x value, y value, and I've created a list from -1 to 1, just so that we can see what's really happening at 0. As you can see right down here, when x is 0, we have an error. So we are correct in assuming that. However, the rest of this table is showing us that even though at 0 there's technically no y value, there is a very clear trend as if the graph is approaching but not quite touching the value of y equals 1. So you see it goes from 0.84, 0.89, 0.94, 0.97, 0.99, then we see our error, and then it kind of falls away, 0.99, 0.97, and so on and so forth. So even though it would not be accurate for us to say that at x equals 0, y equals 1. That would be mathematically incorrect. It wouldn't be a true statement. So when x equals 0, the graph does not equal 1. Y does not equal 1. But it would be true if I were to say the limit of the graph as x is heading towards 0 is y equals 1. So I can't say that when x equals 0, y does equal 1, but I can say that the limit it approaches as we get closer and closer to 0, as x gets closer and closer to 0, is 1. Let me write that out for you in some mathematical symbolism that you're going to come to, well, hopefully you'll come to appreciate. You certainly will become familiar with it. So I'm going to say it would not be true. Let me get my blue pen here. We have a function. Actually, let's do green because that's the color it was in our last one. We're going to choose green. Let me try green. There we go. We have our function, f of x, and it's sine of x divided by x. So it is not true to say that there is a point x equals 0, y equals 1. That is incorrect. But it is correct to say that there is a limit, I'll abbreviate LIM, there's a limit as x is heading towards 0 for this function, f, right? So there's a limit as x goes to 0 for this function, and that limit is 1. In other words, as x heads towards 0, the function is getting closer and closer to 1. And I am allowed to say this, I'm allowed to write this. This is check, it's true, because I'm not saying that the function equals 1. I'm saying the limit, what we're getting closer and closer to, that limit is heading towards 1. And that's what a limit is. It's just saying that it's kind of like waving your hands in the air and saying it's pretty much 1. It's not really, but it's so close, in fact, infinitely close, so let's just call it 1. But that's kind of not mathematical to wave your hands in the air and say that, so that's why we create, let me just show you one more time. We show you this, this symbolism that says that the limit as x goes to 0 of f of x is 1. And that's it. So we're going to close out with that for our topic 1. In topic 2, let's discuss what we're allowed to do or not do with limits and look at a few example problems.